Allumage et décollage.
Buonasera, benvenuti a tutti in Guiana francese. Hello and welcome to the Guiana Space Center. Soyez les bienvenus à Kourou, port spatial de l'Europe. Nous allons ici, dans ce centre Jupiter, vous faire vivre tout bonnement ce troisième lancement de l'année, un lancement aux couleurs de l'Italie. Imaginez un lanceur conçu et réalisé par Avio pour le compte de l'Europe et sous la coiffe PRISMA, un satellite de l'agence spatiale italienne. Vous allez découvrir tout cela tout au long de cette émission, mais on retrouve tout de suite la commentatrice anglophone Katie Aswell qui est au plus près des équipes. So Katie, it's over to you.
Thank you very much indeed, Thierry. Yes, and indeed a big welcome to everybody joining us tonight for our live broadcast here at the Guiana Space Center, the third launch this year. And as Thierry said, we are flying the Italian colours today because we are launching an Italian satellite called PRISMA. Right now it's inside the launcher waiting for liftoff. That's scheduled in roughly 13 minutes' time. Now, the Executive Vice President of Missions, Purchasing and Operations at Arianespace is Luce Fabregat. It may be a long title, but she knows all about tonight's mission. And thanks indeed for joining us on the floor, Luce. So it is an all-Italian mission tonight.
Yes, you're right. It's a very Italian launch tonight. We launch Italian satellite built by Italian industry under the leadership of our customer of tonight, OHB Italia and Leonardo. And this satellite is for the Italian Space Agency. And the launcher also is very Italian because it was manufactured under the leadership of the Avio, the prime contractor. And so today I would like to say benvenuti a tutti.
And Luce, so we are 12 minutes now until launch. What's been happening so far in the countdown?
We started the countdown about 9 hours ago at the beginning of the afternoon here in French Guiana. Since then, we have removed the mobile gantry. We have done all the operations to prepare the launcher for the launch, for the liftoff. And so now it has become more and more autonomous, more and more ready for the launch.
So after liftoff, what's going to happen? What can we expect to see? Because it's going to take about just under an hour, isn't it, to deliver our satellite?
Yes, the mission will last a little less than 1 hour. The launcher will flow towards the north over the Atlantic Ocean. We will have first the ascent phase that will be performed by the 3 solid propellant stages. Then the upper stage will be separated with a satellite, of course, on it. And then the upper stage, we will have with the upper stage a first boost of the AVUM, a little less than 5 minutes. It will be up to, I would say, Canada. And then we will be at an altitude, a very, very huge speed, an altitude of 200 kilometers, which is not so high. And then we will have a long ballistic phase of around 40 minutes, going up to the North Pole, and then on the other side of the Earth, going down up to Indonesia. And then at that point, the upper stage with the satellite will be around 600 kilometers altitude. And at that point, the main engine, will be reignited for a little more than 1 minute before the separation of the satellite.
Wonderful. Well, I wish you all the very best. Luce Fabregat, ladies and gentlemen, thank you very much indeed.
Thanks.
So we're going to find out now. We'll be looking to see what's been happening in the launch campaign.
Welcome everybody, benvenuti a tutti.
The launch campaign has started with the arrival of 747 cargo plane the 11th of January. PRISMA was transferred with the ground support equipment to the Guiana Space Center Preparation Payload Facility S1. After its arrival in this building, OHB Italia team successfully completed all the mechanical, pneumatic and electrical checkouts. Then the final preparations were performed before the spacecraft transfer to the S5 fueling facility on the 8th of February. Propellant filling operations were smoothly carried out without any anomaly 13 and 14 of February. After a few days of finalization, PRISMA was ready to start combined operation with launcher on the 18th of February.
The first stage of the launcher is mainly composed of the P80 solid rocket motor, an engine containing about 88 tons of solid propellant. The launcher stage, directly on the launch table, is transported vertically on a track to the launching area. The second stage of the launcher, with the VV23 engine of about 23 tons of solid propellant, and the third stage of the launcher, with the VV09 motor of about 10 tons of solid propellant, are manufactured in Italy, in the Avio facilities of Colleferro, and transported to Guyana by boat. The stages are then transported to the launch area and integrated on the previous stage to complete the launcher. The fourth stage of the Vega launcher, with the Avum engine, has a liquid propulsion with storable propellants. It was integrated on the launcher on February the 8th, completing the launcher's integration after 12 campaign days. Over the next 2 weeks, launcher acceptance tests were completed. These tests verified the functioning of the electronic equipment until the simulation of the flight mission, the synthesis test, which took place on February the 22nd. Fluidic acceptance tests were completed on February the 23rd with the combustion chamber and RAX subsystem tests. The PRISMA satellite was then transported inside the fairing on February the 28th and integrated on the launcher the day after.
At D-3, we have performed the general dress rehearsal for the range, the launcher and the spacecraft, with all tracking stations involved in the final chronology on the flight. The Vega launch readiness review held on D-1 authorized the beginning of the final chronology to launch the VV14 mission.
Well, I've come up to my commentary box now, which is in the Mission Control Center, and that's what we're looking at, the Mission Control Center there from the outside. And back here we can see the Flight Directorate, Arianespace top management. Luce Fabriguet, who we just chatted with, is heading up this team today. Top management from Arianespace and Avio. And Ettore Scardecchia ran the Kourou Marathon on Sunday and he came second, so huge congratulations to him. We're travelling on board the 14th Vega launcher since it entered service 7 years ago, and as we've heard, it's flight number 14, VV14. That means Vol Vega 14. We have 3 launch vehicles here at the Guiana Space Center. Vega's the baby of the family. She stands 30 meters tall. She weighs in at 138 tons. Take a look at the top of the vehicle. Inside there is our satellite. We call this pointy top of the vehicle the fairing. That's what PRISMA looks like. And as we said earlier, really this is an all-Italian launch because we're orbiting an Italian satellite built by an Italian, the Italian prime contractors OHB Italia and Leonardo Space and Airborne Systems on behalf of the Italian Space Agency, ASI, and it's all travelling on board a rocket conceived, designed and built by the Italian prime contractor Avio, who leads a consortium of European industries all working together. That's what I call teamwork. Now this is the Mission Control Center, and on the right is not the real Ariane 5. It is a model, a near life-size model, but not quite as big as the real thing. And inside that building we saw, this is the Mission Control Center and the operational teams focusing hard Now, at this point before the launch, now, as Luce said, the final countdown started just over 9 hours ago. And during that time, there were various major moments. The onboard computer was activated at L, if we say L is launch, L minus 4 hours and 40 minutes. The mobile gantry withdrew 3 hours and 15 minutes before launch. And the entire system was ready at minus 50 minutes. Now we're coming up to the next important milestone.
À tous de DDO, attention pour la séquence finale lanceur. Top, I0 moins 4 minutes.
And the Range Operations Manager has announced the beginning of the synchronized sequence. This is the automated sequence. The computers are now controlling all the final checks in the countdown. They manage an impressive list of operations. And all of those systems across the base send information about their health status to these panels, which we can see on the right side of your screen. And we call them the status panels. They are showing us the status of 3 main systems: the rocket and pad, the range, and the satellite. The range is the name we give to the spaceport. The base here is about 750 kilometers squared, and that also includes the tracking stations, which are downrange of the spaceport. Now, we have a couple of control centers. Obviously, we've been looking at mission control, which is in charge of the whole mission. This is the launch control center. These teams are in charge of everything to do with the launcher and the pad. And then we have a number of different teams working in here, but primarily one of them is responsible for the operations on the ground, coordinating with mission control for authorization to launch. And everything, if everything goes according to plan, they're the team who trigger the automated sequence, and then the other team is responsible for the flight readiness of the vehicle, overseeing all the operations from assembly of the launcher to the moment of launch. We have quality teams as well working alongside them, making sure that everybody is adhering to the strict set of procedures. And they're based in a blockhouse, protected blockhouse, which is about a couple of kilometers from this pad. So they're very close to the pad. They're watching over all this final phase of the synchronized sequence. We're 1 minute now and 37 seconds to launch. Here are all the VIP guests who you saw inside the Mission Control Center are now coming outside onto the terraces outside to go and watch the launch with their own eyes rather than watching it on the screens here.
À tous de DDO, attention pour moins 1 minute.
Coming up to the 1 minute mark.
Top, I0 moins 1 minute.
And we're 1 minute to launch. Time to say our very best wishes to everybody who's worked so hard for today, to the PRISMA teams, the industrial consortia led by OHB Italia and Leonardo, the Italian Space Agency, the operational teams who are waiting to fly their satellite once it's separated, to CNES, ESA, Arianespace, and of course to all of you who are watching us on the internet. Good luck, everybody, for the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage du V14 PRISMA. Propulsion nominale. Propulsion nominale. Acquisition de la télémesure par la station de Saint-Jean. Pilotage calme, propulsion nominale.
And they are off. PRISMA has started its
P80
journey. Vega blazing a trail across the night sky here in the skies over the Guiana Space Center. The Vega launcher takes its name from the brightest star in the galaxy of
Trajectoire nominale.
constellation of Lyra. Fifth brightest star in the night sky, and tonight she is lighting up our night sky. Heading north now over the Atlantic.
Séparation P80.
And we can see the separation there of the first stage.
Allumage Z23.
And he's telling us that the second stage is switching on, the Z23. This is what we're looking at now.
Propulsion Z23 nominale.
He's telling us that the propulsion of the engine is nominal.
Début de la manœuvre de dogleg.
And there's the beginning of the dog leg maneuver. The dog leg maneuver is taking us out towards the north because we've been flying rather like an aeroplane. When it takes off, it has to go on a certain trajectory because it comes off the, I was about to say launch pad, but the runway, of course. And then depending on which direction it's going in, it turns and flies in that direction, and that's what the dog leg is. We have turned and we're flying towards the north, and he's telling us that everything is going normally. Top right-hand side of the screen is our trajectory. The cross is the actual position of the launcher. End of the dogleg maneuver, and all the parameters are normal, he says. And you could see just at the bottom of the screen there, we'll be seeing it again. There we go. Our altitude, 134 kilometers above our planet. On the bottom left of the screen. In the middle, our distance. That's the distance from the pad, if you were to draw a straight line, from the pad across the Earth to the position where the launcher is over.
Séparation Z23.
On the right, the speed, and now confirmation of the separation of the Z23 stage. Burnt its fuel, we don't need it anymore. There's a few seconds.
Z9.
Now we have a confirmation of the
Séparation de la coiffe.
Z9 is now switched on, and the engine, the fairing, has now been
nominal.
jettisoned. The propulsion, he says, is nominal. So we don't need the fairing anymore. It was protecting our satellite from the rigors of the launch. It was protecting us from friction. It was protecting us from the acoustic vibrations at liftoff. I'm sure you can imagine just how loud that is, or was. And so we are officially in space. This is what it looked like. We lifted off from the pad 4 minutes and 40 seconds ago. From the pad, you can see it there in the Guiana Space Center on the northeastern coast of South America. Galileo is the tracking station at the Guiana Space Center. Vega shot into the sky.
Fin de mission sauvegarde.
shot into the sky, and it was a beautiful launch. We managed to see it all the way until the separation of the first stage, so that we were very, very lucky. We've crossed the threshold. Crossed the threshold into space a little while ago. That was 100 kilometers above our Earth. We call it the Kármán line, the border with space. At that point, the atmosphere is so thin that it can no longer support vehicles with wings. So if we want to stay up once we're above the Kármán line, we have to use rocket science to do that. We're looking on the right-hand side of the screen at computer-generated images. The experts put a series of data and predictions into the computer, and this is a simulation of those predictions, so a simulation of exactly what's been planned for the flight. It's great because it means we can visualize it, we can see what it looks like up there.
Séparation Z9.
And we have separation of the Z9, Z for Zefiro, a kind of wind, an Italian wind, a little bit like the Sirocco or the Mistral. So, third stage has switched off its engine. The main propulsion phase of the flight is now over. And we are picking up the signal at the tracking station in Bermuda, an island in the Caribbean. And correct me if I'm wrong, I think the tracking station is actually on Cooper's Island, which is just to the east of Bermuda. In fact, the teams at the Bermuda tracking station have been a long time space partner, dating back actually to the NASA days of the first manned space program. That was called Mercury, late 1950s and early 60s. And then, of course, as well with the Apollo lunar program in the 1960s. Our flight path takes us north, as Luz described earlier, heading up over the Caribbean, along the east coast of the US, east coast of Canada.
Fin d'acquisition d'un télémesure par la station de Galileo.
And the Galileo tracking station has now, we've now gone out of range of the Galileo tracking station. That's the one that was at the Guiana Space Center.
Allumage AVUM.
And we've switched on the engine of the AVUM first stage, or AVUM as it's pronounced in French and maybe in Italian as well. So we've really started the next phase of our journey now.
Nominal.
Everything's going according to plan, he says. So AVUM has taken the wheel, and its job is to deliver our satellite to its required drop-off in space. It has to climb us up to 625 kilometers above the Earth to do that. You can see on the top right-hand side of our screen how we started off climbing quite steeply, and we're plateauing out now. Our altitude at the moment 253 kilometers, so we've still got another few hundred kilometers to go.
Propulsion nominale.
Today is Vega's 14th mission for Earth observation. Sorry, it's 14th mission in total, and 11 of those have been for Earth observation satellites. You can see our flight path there, heading, although we've gone into the range of the Bermuda tracking station, we haven't actually got to Bermuda yet. Yeah, so Earth observation involves using satellites in space to gather information about the physical, chemical and biological systems of our planet. And PRISMA is going to do a very important job. So let's find out more now about our satellite.
Propulsion nominale, les paramètres à bord sont conformes à la donnée.
And during that film, we
Il
picked
reste
up...
moins d'1 minute de propulsion de la VOM.
He's telling us we've got 1 minute left of propulsion on the upper stage. And we picked up the signal at the tracking station in Canada during that film. It's in Saint-Hubert or Saint-Hubert in Quebec, just outside Montreal. And the aerospace industry is important there too. The Canadian Space Agency has its head office in the borough. Now we're tracking using telemetry. So these tracking stations have big dishes which pick up the signal from the launcher as it flies over, and that information then gets sent here to the CVI, the teams here
nominal.
At the Guiana Space Center, telling us how the flight's progressing in real time. Those are the 3 tracking stations.
Première extinction du moteur à VOM.
And we have the switch off of the upper stage engine now. So we're entering the first ballistic stage. Ballistic's a word that we often hear, but what does it actually mean? Well, I believe that it means that we are travelling without propulsion. And that's what we're doing right now, because we are high enough and fast enough to cruise without the engine. And this ballistic phase is going to last for 38 minutes, roughly. We're also doing various manoeuvres here. The upper stage is a very clever piece of kit. It's called the AVUM because that stands for Attitude and Vernier Upper Module. It's the smart part of the launcher. It's the command and guidance module. It's a little bit like the cockpit in an aeroplane. Its job is to deliver our satellite to a very specific orbit. And it's designed to inject different payloads into different orbits because each satellite requires a different separation orbit, a different place to be deposited, if you like, or delivered to in space.
L'étage à VOM est en phase balistique.
He's just confirmed that the AVUM upper stage is in the ballistic phase. And so that's why it can switch its engine on and off so that it can take its passengers anywhere they need to go. It's a little bit like a sophisticated taxi driver. You can see it twisting, can you? Looking a little bit like it's on a spit. Well, I believe it is right now in what we call the barbecue phase. Let's hear more about our satellite from our Italian friends.
Tonight, Vega launcher will deliver PRISMA spacecraft to a sun-synchronous orbit at an altitude of 615 kilometers. PRISMA, precursore iperspettrale della missione applicativa, is an Earth observation satellite mission funded by Italian Space Agency.
PRISMA is a full Italian Earth observation mission based on a single satellite, carrying an hyperspectral imager that will characterize the Earth's surface on a global scale, extracting geochemical, biochemical, and biophysical parameters, providing unique information on the status and evolution of our planet. Hyperspectral imaging is an innovative remote sensing technology that acquires image data in hundreds of narrow continuous bands, from the visible to the shortwave infrared. Each individual pixel of the hyperspectral image contains a continuous spectrum of the solar radiation reflected by the surface. These spectra include absorption features, which can be interpreted as spectral fingerprints of Earth elements that allows to identify minerals in rocks and soils, to analyze vegetation types and conditions, and to detect pollutants in water and air. PRISMA missions have been developed under the aegis of my agency, the Italian Space Agency, through a joint venture of Italian companies led by OHB Italia, responsible for the platform and the system, and Leonardo, which built the electro-optical instrument.
The satellite platform has been designed and developed specifically for PRISMA by OHB Italia. The principal electronic units have been realized in Italy by us and our partners, including the onboard computer, the power control and distribution unit, the tube batteries, and the payload data management unit. In doing this, the PRISMA industrial comport has maximized the reuse of the heritage from the previous missions funded by ASI and by ESA. The assembly, integration and test of the satellite has occurred in OHB Italia clean rooms located in the north of Italy, starting from beginning of 2018 and involving several months of very intensive job for all our company, which makes us very proud of that.
We are very proud of PRISMA at Leonardo, where we designed, developed, tested and calibrated the payload for Italian Space Agency. For 10 years, about 100 people worked for this project in Campi Bisenzio, near Florence. It was a big technological challenge that we faced thanks to the commitment of the team and the strong support of Italian Space Agency. At Leonardo, innovation is one of our values, and the PRISMA is a true example of how innovation becomes a valuable product. The payload capitalizes several new technologies, such as a challenging passive cooling system, optical coating, and advanced processing for image quality. The program is the result of an excellent cooperation among Leonardo and OHB Italia and many other Italian small and medium companies.
The scientific community and other users will be able to employ these capabilities for a number of applications, including environmental monitoring, resource management, identification and classification of crops, the fight against pollution. For Arianespace, the journey for preparing the PRISMA mission began in June 2017. Since then, many milestones have been accomplished to reach this final and actual successful step. I'd like to thank all the teams involved in this program for their professionality and spirit of
La prochaine
cooperation.
acquisition de la télémesure lanceur est prévue dans environ 30 minutes par la station de Nunorcia en Australie.
So telling us in about 30 minutes' time that we'll be picking up the signal at the tracking station in New Norcia, that's in Australia. And PRISMA will be the third satellite which Arianespace will have launched on behalf of the Italian space agency ASI. There are 2 more to launch, 2 more in the order book. They're actually a pair of satellites, and they are called Cosmo SkyMed Second Generation. They are scheduled to lift off on board a Soyuz and a Vega C. And Thales Alenia Space built them for ASI and the Italian Ministry of Defence. So that's a nice launch to look forward to, or 2 nice launches to look forward to. So the Avum upper stage is due to switch its engine on again in about 32 minutes' time for its second burn. We're going to take a break now for about 25 minutes. And during that time, we'll have a planned gap in visibility because we'll go outside the range of the ground stations for a little while. So during that time, we won't be getting any information from the launcher. That's all perfectly normal. It'll download the information to New Norcia when it gets there. And so I'm going to be coming back to you at 11:34 p.m. here in Kourou. That's in Italy, 3:34 in the morning. And universal time, that's 2:34 in the morning. In the meantime, we're going to leave you with a beautiful replay of our launch 20 minutes ago. We'll see you back here in about 22 minutes' time. Again, and welcome back. You join us live. We're coming to you from the Guiana Space Center on the northeastern coast of South America. This is our drone flying over a part of the spaceport here in Amazonia. That's the Mission Control Center. You can see with the model of the Ariane 5 launcher. We're 44 minutes and 17 seconds into the flight of PRISMA, an Italian Earth observation satellite for Italy. We lifted off from the pad, as I said, over 44 minutes ago, so here is the story so far.
The VV14 mission is a single-payload mission whose target is putting the satellite PRISMA into the required orbit. The target orbit for this mission is a sun-synchronous orbit with an altitude of 615 kilometers. The liftoff time for this flight occurred at 22 hours, 50 minutes and 35 seconds in Kourou local time. The total mass of the launch vehicle at liftoff was about 138 tons compared to the required performance for this mission of 1 ton. In order to enable the Vega launch vehicle to take off, the first stage, P80, produced a thrust of 2200 kilonewtons at beginning of flight. During the first flight phases, the solid booster stages P80, VV23 and VV9 have been tracked by the telemetry ground station Galileo over a duration of 7 minutes. The upper stage, integrating the liquid propulsion engine AVOM, has reached a transfer orbit after a first boost duration of 5 minutes. This boost has been tracked by the Bermuda ground station and by the Canadian Saint-Hubert station. Following this long intermediate ballistic phase of 39 minutes, and in order to make the SS orbit circular, a second shorter boost of 1 minute will occur under the visibility of the Australian New Norcia station. Once the target orbit reached, PRISMA will be released. This will occur approximately 54 minutes from the liftoff. After a full round around the Earth, in order to inject the launch vehicle in a re-entry trajectory, a last AVOM boost will be performed over a duration of 90 seconds, and it will be ground-tracked by the Bermuda station.
So, you can see on the top right-hand side is our trajectory, and the bottom of the screen. Our altitude, 605 kilometers above our planet. We need to get to 625 kilometers to separate our satellite, so we're not far away in terms of the altitude. And our distance from the pad on the middle is the distance if you were to draw a straight line across our Earth. Once the satellite's released, it's going to go through a series of initial tests. We call it LEOPS.
Once released by the launcher, it will autonomously switch on and start the automatic sequence to reach the 3-axis stabilized attitude in space by pointing its solar array toward the Sun. From that moment, we foresee to perform some days of LEOP activity, aimed to put the satellite in AOC standby mode and activate the payload. The IoT phase will start just after the completion of the LEOP. During that time, our team of engineers will perform a series of tests aimed to check all the satellite subsystems behavior up to the final verification of the payload functionality. The control of the mission will be done by the ground station located at Fucino in Italy by a joint team of experts that will cover all the aspects from orbital control to subsystems monitoring. The payload data will be downloaded to the ASI CNM at Matera, where they will be processed to generate the image products, archived and made available to the users. Globally, we plan to have a commissioning phase of 3 months, where the last part will be aimed to the in-flight qualification of the system, before entering in its 5 years operative lifetime. Today's launch of PRISMA satellite is the output of the valuable collaboration we have established between all the parties, starting from Leonardo, our partner in the PRISMA contractual joint venture and supplier of the payload, and including an essential support from our customer ASI.
So all of those teams working together, and that's what's going to happen once the satellite is separated. But right now, 48 minutes, coming up to 49 minutes, getting closer to our separation time, still about 6 minutes away. And our speed on the bottom right-hand side is 754 kilometers, and you can see that's not changing. That's because we are in the ballistic phase. Just a reminder that that means we are coasting without the engine, heading towards our next tracking station, which is New Norcia. And we're scheduled to pick the signal up there at the New Norcia tracking station. You can see it on the bottom right-hand side of the globe. It's we've come over the North Pole, and the teams who receive the information here at the Guiana Space Center are the CVI teams. And we're looking at these guys and girls now. They are called the Real-Time Visual Control Team. Basically, the tracking stations send the information, the data from the vehicle, from the launcher, to these teams, and they then go through the data and they can track what's happening to the vehicle in real time. They can also do an evaluation afterwards.
Réacquisition de la télémesure par la station de New Norcia.
So he's telling us that we've picked up the signal at the New Norcia tracking station. We've now gone into the range of New Norcia, which is on the west coast of Australia. So we've done not quite a full lap of the Earth yet, but we've done about half a lap of the Earth. And it's actually an ESA, European Space Agency, deep space tracking station. It's 150 kilometers north of Perth, I believe, in Western Australia.
Début de la manœuvre d'orientation avant le deuxième allumage à Vaume.
He's just telling us, excuse me, that the upper stage has now started its orientation mover, getting ready to switch its engine on.
Barbecue.
And we've just finished the barbecue phase, a technical term
Deuxième
indeed,
allumage à Vaume.
for the rotational phase when we rotate as if on a spit to keep those thermal temperatures nice and even. So now we've switched on our engine for... We've switched the engine on for a second burn. He's telling us that everything's nominal. And that's the journey we've done so far. We flew over the top of the planet, over the north, over the ice, heading back down towards the sunshine now.
Nominal.
Coming down over Southeast Asia towards Western Australia. Ava
Reste moins de
is
30 secondes de propulsion de la Vaume.
30 seconds left of propulsion on the upper stage. It's the upper stage is the conical shape there with the engine burning, and it's the smart stage, the clever stage. The upper module contains the avionics, that's flight control systems, navigation, communications, that kind of thing. And the lower module is the propulsion module and contains 4 tanks containing 2
de la Vaume.
types of liquid propellant, and those have been now burnt out because we are switching off the engine. Liquid propellant is very useful for the upper stage because it gives it more precision.
Début de la manœuvre d'orientation au profit de PRISMA.
And now beginning of the orientation phase to start putting PRISMA into its correct orientation to be separated. So we're now on orbit. Look at the bottom left. We're 625 kilometers above Earth. That's our separation orbit. This is what it looks like up there.
Fin de la manœuvre d'orientation au profit de PRISMA.
This is PRISMA's view of our planet. And the upper stage is going through a very precise and very carefully planned set of maneuvers. We need to orientate our satellite absolutely correctly, and so that we can put it onto the perfect path for it to be able to then go through its next set of operations once it's been separated. In order to orientate the upper stage, AVM has 2 sets of monopropellant thrusters which control role and attitude, and he has confirmed that we have separation of the PRISMA satellite, and that's what it looks like. The satellite is pushed away by a set of springs. It is pinged into space, all very carefully planned for collision avoidance. And this is good news. Italy has a new satellite. Our warmest congratulations. Our warmest congratulations to the PRISMA teams, to the Italian Space Agency, the industrial consortia, led by OHB Italia and Leonardo. Well done, everybody. There's some very happy, smiling faces there. A job well done. So many hundreds of people have worked so hard to get PRISMA to this position in space. A new baby has now been born. But of course, the work may be ending for some, and it's beginning for others, because PRISMA is now heading out on its own to start its new life in space. And the teams who fly the satellite, if you like, the operational teams in the control center on the ground. Bear hug. Those teams on the ground are now taking control of their satellites, so our very best wishes to you as you take charge of your new baby. PRISMA has an important job to do. It's going to help us to better understand our planet, and Italy will be very pleased to have their new satellite in space, delivered by Vega. And this was the launch 55 minutes ago, lifting off from the pad here at the Guiana Space Center in South America, in Amazonia. It really was a sensational launch. We were very lucky. We saw the launcher going deep into space, and we managed to follow it with our cameras all the way to seeing the first stage falling away. Waiting now for the official speeches and for Luce Fabregat and a number of other people to take the floor. I'm sure everyone's feeling very proud of their work, and I hope that people are giving themselves a big slap on the back. And congratulations to everybody.
Ladies and gentlemen, distinguished guests, Arianespace is delighted to announce that PRISMA has been separated as planned on its targeted sun-synchronous orbit. There was no better way for Vega to start the year 2019 than with this 14th success in a row. Congratulations to all. Tonight, I want to deeply thank our customers and partners and say how proud we are to have orbited the PRISMA satellite. This state-of-the-art bird, embarking new generation hyperspectral technologies, is a new proof of the Italian savoir-faire at the service of citizens. For having entrusted Arianespace with such a critical mission, I want first to thank our direct customer, OHB Italia, and notably its CEO, Roberto Accetti, here with us at CSG. Thank you, Roberto. This successful launch adds up to our partnership, already extended a few months ago with the signature of NAOS, the launch contract to the benefit of Luxembourg. Thank you for your trust. Today, I want to say complimenti a tutti for the delivery of this advanced satellite built by the industrial consortium led by OHB Italia and Leonardo. Let me thank also Isabella Groppi, Senior Vice President, Space Line of Business at Leonardo, for being here with us tonight. Arianespace is even prouder to orbit PRISMA, which will help Italy to monitor the environment and ensure citizen security. The PRISMA satellite is fully in accordance with Arianespace's motto, space at the service of a better life on Earth. In this regard, I want to thank the final customer of the mission, the Italian space agency, ASI, for its trust. On this occasion, I would like to thank you, Giovanni Cinque, ASI's sub-commissioner, for being with us also tonight. PRISMA is the 8th satellite Arianespace has launched for Italy with Ariane, Soyuz, and Vega. And our Italian partners are not only key actors involved in the European launchers, but also you are key institutional customers for Arianespace. With tonight's flight, Arianespace once more fulfilled its mission, ensuring Europe an independent and reliable access to space. And we will keep on. We will have further opportunities to welcome ASI's teams as our current and next generation of European launchers, as you know, will keep on delivering to the benefit of Italy. Notably, the two Cosmos Skymet second generation satellites will fly soon from here, from the CSG, on Soyuz by the end of this year and on Vega C next year. Vega C and Ariane 6 were designed complementary around the P120C booster produced by Avio in its Colleferro facilities. Hence, we are glad we can count on the support of Italy, both as a launcher partner and as a loyal customer. With this new success for Vega, Arianespace flied its 600th satellite tonight, symbol of Vega performance on this market segment. PRISMA is also the 70th Earth observation satellite launched by the European launchers family. I want to congratulate all our partners for the latter success, starting with Avio, the Vega prime contractor. Bravissimo to the teams that have been working so hard this last day. Thank you to all of you. This last success of Vega is paving the way to other 3 Vega flight opportunities in 2019 and to the new successes we envision for Vega C. At a time we are busy already preparing its maiden flight, beginning of next year. Congratulations also to the European Space Agency and national agencies, notably ASI, for your continuous support to the Vega program. Thank you, Stefano, for your huge support to this program. Many thanks also to CNES, to those who have been working like hell these last days also. They are our daily partner here in CSG, as well as our contractors. Also, thanks to our contractors in French Guiana and all employees at the launch facility. Of course, congratulations also to all my Arianespace colleagues. Here is to the 3rd success of 2019. Dear customers, dear partners, the floor is now yours. Thank you.
Questa è una serata italiana. Perdonatemi dunque se mi esprimo in italiano. Una persona che stimo stamattina mi ha ricordato che sono pochi gli italiani che rammentano che l'Italia è il terzo paese al mondo ad aver spedito in orbita un satellite dopo Stati Uniti e Russia. Il mio auspicio è che domani quante più persone, soprattutto gli italiani, sappiano che l'Italia è il primo paese d'Europa ad aver lanciato in orbita un satellite con un sensore ottico iperspettrale. PRISMA è l'esempio mirabile di cosa può produrre il comparto spaziale italiano quando decide di fare gioco di squadra e interpretare collettivamente la partita. Circa 12 anni fa, ASI, l'Agenzia Spaziale Italiana, che stasera ho l'onore di rappresentare, decise di stanziare, di finanziare con risorse pubbliche il progetto PRISMA e selezionò le imprese che hanno realizzato l'oggetto che stasera abbiamo osservato. OHB Italia, capofila di un raggruppamento temporaneo di imprese, è responsabile della missione e si è occupata e si occupa dei segmenti di attività più rilevanti, lancio, terra e volo. Leonardo ha messo a disposizione le competenze per la realizzazione dell'occhio iperspettrale. Avio, italiana anch'essa, produce Vega, che concettualmente per costruzione è prevalentemente italiano. Il centro di raccolta dati è stato realizzato da Telespazio. Il centro che processerà i dati che proverranno da PRISMA è italiano ed è il centro spaziale di Matera. Tutto questo vuol dire che il comparto spaziale italiano ha un enorme potenziale. Il 2018 è stato un anno importante per lo spazio in Italia. È entrata in vigore la legge 7, conosciuta come la legge Spazio, che ha rimesso sotto la competenza del Governo e della Presidenza del Consiglio dei Ministri la materia dello spazio. Il Governo la esercita attraverso il COMINT, un comitato interministeriale dove siedono tutti i ministeri che hanno un diretto interesse in questa materia. Vi siede e vi partecipa l'Agenzia Spaziale Italiana, possono sedervi e partecipare tutti gli esponenti del mondo della ricerca, dell'università e dell'industria, e credo che quello sia il luogo istituzionalmente deputato a fare in modo che tutte queste potenzialità possano tradursi in una filiera costante di successi come quello che abbiamo vissuto e che ho vissuto stasera sulla nostra pelle. Grazie.
Bien fait, ESA, Stefano, bien fait à Arianespace, à la CNES. Avec ces lancements, PRISMA, ce n'est pas seulement un succès italien, c'est un succès européen. Donc, merci à toutes les personnes qui ont travaillé à ce projet ici à Kourou. Je pense que c'est important de remarquer ça en cette occasion. Turning to English, sorry, I have sort of came to an end to my French vocabulary. I'm sorry about that. But I just wanted to take the opportunity again to thank everybody for the fantastic job. Thanking particularly Avio, which has yet again proven its reliability and will continue to be our reference launcher for our project. We have already the next project line up and with a contract signed, which is now, and I'm working to further opportunities to use this launcher. And I'm more and more convinced that this is a workhorse that deserves all our attention and our commitment. Grazie, turning to Italian, grazie a tutti I colleghi dell'azienda che dirigo, dei miei partner Leonardo, di Avio ancora una volta e tutte le aziende che diciamo, hanno collaborato a questo grande successo e la dedizione degli ingegneri che hanno lavorato alacremente. Gli ultimi 4-5 mesi i miei colleghi sanno che sono stati costretti a turni e quindi il mio sentito ringraziamento va a voi. So quanto avete dato e adesso è venuto il momento di raccogliere. Posso solo augurarmi che in seguito alle operazioni che ci attendono, il commissioning e poi alle operations, questo satellite mantenga le promesse, così che si possa fare di questa missione pilota un'infrastruttura permanente per il nostro Paese che investe così tanto dello spazio. So thank you so much and to the next launch.
Thank you, and so again, congratulations to all for this outstanding success. We'll be back here in April, on the 4th of April, for our next launch with Soyuz. It will be the 5th launch for O3b, SES O3b. And I would like really to thank you for your attention tonight and to wish you to enjoy the night. Thank you.
Eh bien, voilà. Voilà donc cette émission qui s'achève. On observe notre ami drone de loin. Nous sommes sur la terrasse avec Cathy. On va prendre congé. J'espère que vous avez passé un bon moment. Nous, ça a été vraiment un moment très, très agréable en compagnie de toutes ces équipes, de ce lanceur Vega, des équipes de PRISMA, un peu d'Italie déposée ici sur les bords, sur les rives de l'océan en Guyane. Alors, il ne vous reste plus qu'à vous souhaiter écoutez, une belle nuit, bella notte a tutti. Cathy, toi, tu seras bientôt là, toi?
Well, I will. And for all our friends who don't speak French, Thierry is telling everybody that I'll be coming back for the next launch. I just want to say, well done, everybody, and congratulations. Mission accomplished tonight. 14 out of 14 for Vega. Successful launches. We have been so happy to have you with us, and I hope that you'll be joining us again. I hope you enjoyed our show, and I hope to see you again next time for the O3b launch. But from Thierry and from me, it's arrivederci. Goodbye. Ciao, ciao. Bye.
3, 2, 1, top, allumage et décollage.